And welcome back, and it is the Corbett Maths 22nd of March, 5 a day for further maths. And let's just get straight to the first question. Right, so it looks like a surds question. What do we need to do? Always have in mind where you're trying to get to. So I'm trying to get to something plus something times root 3, which, looking at the question, is probably just going to fall out. But anyway, let's give it a go. So usual expansion of brackets, multiply both on the right hand side by 1. That's going to give me 5 minus root 3. Then multiply, so I've done the 1, so multiply both in the right hand side by 4 root 3. Well, 4 times 5 is 20, so that's going to give me 20 lots of root 3. And 4 times root 3 times root 3 is 4 times 3, which is 12, and then I'm taking that away, so that's minus 12. Now, I've got negatives to start, but I'm going to keep the convention of what the answer wants. So 5 minus 12 is going to give me minus 7, and minus 3, or minus 1 lot of root 3 plus 20 root 3s is plus 19 root 3s. So in the same order the question gives it, that's my final answer. Next question. All right, so what do we have here? So AB equals BC, it tells me that already. So isosceles triangles, which means base angles are equal. So these two angles are equal already. And then it says ACE and BCD are straight line, BDE are straight lines. Okay, so just confirming something that's obvious. Prove that the angle BCA equals CDE. Now, as I always say whenever I do these questions, so I won't write full reasons because you'll just be watching me write a lot of text, but I'll talk through exactly what you need to write to make sure it's clear. First of all, let's work out what we are trying to do. So we're trying to show that BCA, which is this angle here, is equal to CDE, which is going to be this angle here. So not immediately obvious what I'm going to do here, but I'm going to start with the isosceles triangle because that feels like that might be relevant. And I'm pausing because I've just seen what's supposed to happen. Okay, so the first thing I would say is well, I'd actually start by saying ACB. So ACB is equal to X. Just means I can use the word X then. It just makes it a bit easier. Which means that CAB is equal to X. Now, it's not just because it's isosceles, it's because it's an isosceles triangle. And where the important words are base angles are equal. So you're saying in an isosceles triangle, you understand the two angles that are opposite the central angle are equal to each other. Now, the bit that I was sort of pausing for a second, I was trying to work out what to do. What's notable is this angle here, so I'm going to call it angle CDB. So angle CDB is equal to 180 minus X. Actually, what I'm going to do is put my X's in as I go. And then I've cut it up to date, so that's 180 minus X. And that is because opposite angles, and this is the key word, in a cyclic quadrilateral add to 180 degrees. Now, having said I wouldn't write it all down, I have now written it all down, haven't I? And that means I can see my answer. So CDE is therefore going to be, so angle CDE is therefore going to be 180 minus 180 minus X, which is going to be equal to X, which is going to be equal to, what am I trying to prove? BCA. So it's going to be angle BCA, and that is because angles on a straight line total 180. Now, the way these are marked is these are marked by specific words. So I'll be looking for the words base angles, looking for the words isosceles. I'll be looking for the opposite angles and the word cyclic quadrilateral. And not just these words, by the way, but lots of words like this will be underlined in the mark scheme, and I'll be looking for you to have said it. So you can't just write straight line or anything similar. Anyway, a bit longer than expected, but either way, question done. Next question. Right, so it's a circle question. And what do we know? Well, actually read what it wants rather than just do some maths anyway. So find the center of the circle, find the radius. So actually this is a pretty, and by this I don't mean in sort of an easy way, but it's just a standard textbooky question, is it? Which I've given you an equation. What can I do to that equation to turn into something that I know how to do? And what you're going to do is you're going to complete the square. So if I look at my x's, actually that's a minus, isn't it? So if I look at my x's, I've got x squared minus 2x, which is the same as x minus 1 all squared, minus the one I don't want. I've completed the square. And my y's are going to be y plus 3 all squared. So I've done my y's, and then I'm taking away the 9 I don't want, and then I'm going to take away another 10. And let's collect all this together. So that's going to be x minus 1 all squared plus y plus 3 all squared. Now, -1 minus 9 is -10. Minus another 10 is 20. Move that to the other side, and that gives me 20. So in other words, the centre of my circle is going to be 1 minus 3, the opposite of these numbers here. And the radius of my circle is going to be the square root of 20, which you could also write as 2 root 5. And that is question done. And indeed, that is today done. So nice little mix of questions today. That middle question was definitely a bit harder, but making sure you know those angle rules. Usual thing, as ever, let me know how you did. Do like and subscribe, and I'll see you for tomorrow. Thanks all.